Hello everyone, my name is Jungnam Gwock. Today I will talk about the line free call, especially focusing on the latest updates. I think the most of you know the fact that line is servicing the free call, and I want to believe many of you are liking line free calling. Actually, we had to develop many features to give you good call service quality. Now let me show the software module diagram to describe in detail. First of all, the core UI phase uses the VoIP client module, and the VoIP module communicates with the VoIP servers to connect another VoIP user. For the duration of the presentation, I will use the term VoIP platform to describe the VoIP client module and VoIP servers as a single unit. During a call initiation and also after the call setup, the VoIP platform does many things to ensure the real-time communication. We have engineered the VoIP platform for many years to enhance call service quality. For example, when the media packet delivery port is blocked, the platform will try to connect 80 or 8080 ports of other TCP servers. This detour network path enables call initiation to be successful under the UDP blocked network. As a matter of fact, we developed many additional functions every time there were needs. However, the software structure of the VoIP platform was not flexible to run such many additional features. In turn, maintenance costs increased. We thought the lifetime of the VoIP platform is almost done. So we have started to develop a new VoIP platform from the bottom, based on the knowledges and experiences we have learned. So we started a project. We named the project as PLANET. Through this project, we hope to move forward to support the higher quality of the real-time communication. The goal of the project is simple. It is to enhance the call quality by replacing the existing VoIP platform. We thought the development is valuable even though it takes a long time. To do that, we had to design the new VoIP platform from the beginning. In fact, the works involved in the project are too many to talk about all of it today. So, first of all, I would like to introduce the major changes made in the project perspective. And then I want to share how the media quality changed in the latest update. PLANET protocols. Some of you here may have heard about SIP. The SIP protocol, which is IETF standard, has been used for a long time as a call setup protocol. Of course, I know that it is used by not only telephone companies, but also other applications that provide VoIP services. In fact, the line free call service also uses the custom protocol based on the SIP protocol. Realistically, there is no existing alternative for SIP. However, we could not stop thinking about this. Does it fit in mobile apps? This topic was very important and sometimes painful because all VoIP services we are offering are based on this SIP. To answer this question, I think we should start by answering some other questions first. Why the SIP is so popular? Just because it is the standard? Why is the SIP? Maybe because the telephone companies and many VoIP solution companies have to work together, and they need many interconnections. The SIP as a standard has a role under these relations. Companies can make clear interface because they have SIP as the standard. That is, the SIP solves the compatibility issues. Now, let's see mobile app development companies. Do you think the mobile app developers can make interconnection between their own web services? For example, can I make call with the line to Apple's FaceTime? I don't think so. Not in a near future. And under these circumstances, it seems unnecessary to adhere the standard SIP. Now let's talk about the packet size. This is another matter. The SIP messages consist of a human readable text. So the messages result in larger packet size. However, it seems clear that the larger the packet, the more issues it creates, especially under the mobile network. From our experience, small data consumption or small packet size is good for the mobile network. So we made a decision to throw away the SIP and designed network-friendly call setup protocol focused on the reducing the packet size and minimizing the network resource usage. There are three major protocols: Cassini, Huygens, and BEPI. Cassini, Huygens, and BEPI replace SIP, SDP, and ICE protocols respectively. Actually, the new protocols do not have the exactly same role as the old ones. For example, Huygens does not negotiate media connection candidates, but negotiates only const capabilities and initial media attributes. These redefined roles allow smaller packet size and simple implementation. Diving into the protocols can be a little bit complicated. Instead of telling you those boring stories, I want to share a comparison experiment on data consumption of commercial VIP apps during call setup. For the experiment, I have captured packets on the caller device with Wireshark tool while calling and answering on several VIP apps. Then I apply the filter to remain only the packet sent or received from a server that is speculated as a call server. Finally, compare maximum data rate during call setup. Here are the results. The call setup data consumption of the first two apps is over 100 kbps. It is too much. In fact, I cannot be sure that all data is used internally for call setup. But every time I made a call and accepted it, it was able to observe this consumption amount. The third app was relatively small amount. And fourth is the old lines free call. We optimize the call setup packet size in the old line version, but it seems like there was a limit because it is based on the SIP. And finally, the new protocol's data consumption is just 21 kilobps. As you can see, it consumes the smallest amount. This implies an increase in the range of networks in which the call connection can be successful. For example, you might be able to connect a call even in a congested situation where the connection may have previously considered unsuccessful. I know the smaller data consumption does not simply mean high quality call connection. There are so many variables in real-time call setup, and many of these problems need to be addressed individually in order to increase the probability of successful call setup. However, we believe that lowering the call flow or data consumption lowers the potential network issues. Therefore, these newly designed network-friendly protocols will provide better quality call connections. Phrased voice. Have you heard about the term phrased voice? Actually, this word has been used for a long time in telecommunication field. The phrased voice is a word describing the voice quality. And there are more words to describe the voice quality, such as narrowband, HD voice, and line free call have serviced the HD voice quality until now. This image shows how much frequency information is included in the HD voice and phrased voice and line free call. As I already said before, have serviced the HD voice quality until now. The phrased voice means you can hear higher frequency in the voice than before. The phrased voice includes frequency from 8 kilo to about 20 kilohertz. But many of you may be wondering, what is the difference? Or what does this mean exactly? As a matter of fact, this difference could be difficult to notice. In simple terms, I can say the clarity of the voice is better. But it is not so simple. Later in this session, I will let you hear the difference between them. Before listening them, I will show you a voice quality comparison chart between commercial VoIP apps. We investigated at the user level, and maybe not be correct in other circumstances. The first two popular apps are HD voice. The old line free call was also HD voice. The app C is super wideband voice. The super wideband is the middle band between HD and phrased voice. However, the third app C can only run on iOS or OS X. As you can see, the latest line free call's voice quality is the only phrased voice quality among tested apps. I have described you until now phrased voice and shared that the newly developed VoIP platform supports the phrased voice quality. But unfortunately, most of you may not be able to hear the phrased voice because it heavily depends on the device capability. Please take a look at the screen. When a human speaks, all frequency elements are included in his/her voice. But the sub microphone device passes only low frequency elements. The experimental device reduces the signal power over the 12 kilohertz, although the sampling rate is 48 samples per sec. So the output signal is similar to the super wideband. This limitation also exists in the playout path. Although we play out full band signal into the speaker device, a certain device reduces over the 12 kilohertz frequency. So a user can only hear such a super wideband quality. I don't know why mobile device makers limit higher frequency sound. We hope that the more mobile devices become capable of recording and playing out the full band as soon as possible. If mobile device makers support recording and play out sound of a higher frequency, many people will be happy. I prepared a material to compare the difference of voice quality between the old line and the latest line version. We can experience the differences right here. The speaker side is the iPhone, and the device reduces the signal power or frequency higher than 12 kilohertz, so that the actual signal becomes a super wideband. This setting appears to be realistic because most line-free core users belong to this setting. Now, you will hear two core recording sources. One is from the existing line FreeCore, and the other is from the new version of FreeCore, HD Voice. Please remember that previous line FreeCore was in HD Voice. And listen carefully and try to hear the differences. In fact, the difference may not be clear because it depends heavily on the room's sound system. But let's do it. Please guess which is the phrased voice. Number 1.
I was astonished by a sudden understanding of that mysterious radiation of the sands. When I was a little boy, I lived in an old house, and legend told us that a treasure was buried there.
And number 2.
I was astonished by a sudden understanding of that mysterious radiation of the sands. When I was a little boy, I lived in an old house, and legend told us that a treasure was buried there.
Can you choose which is the phrased voice? Yeah, I'm actually super wideband. Later is the phrased voice. To distinguish sound clearly, many things must be controlled. Noise, space, sound reproduction equipment, even raw material can affect the sound itself. I agree this room is not the right place to distinguish sounds, but I hope that the difference in sound quality has been conveyed to you. We also hope that these changes close the distance between line-free call users. Video call. Now I will talk about video call. Line video call has also changed a lot, but today I will focus on video quality changes. To improve the video call quality, we need to consider a few factors about the video call. And we have to balance these various factors. First, the image quality itself is very important. This picture quality depends on the camera device and the video codec. The camera on your phone captures the scene you want to send to the other party during a video call. Obviously, a better camera device will make the image better. Indeed, this is not a factor we can change. Let's just assume that the user is using a mobile device with a good camera, and the image is compressed with a video codec. This is our area. Generally speaking, the higher compression rate, the lower the image quality. Therefore, to increase the picture quality, we have to lower the compression ratio. Let's take a look at another factor, network adaptation. Network adaptation is also very important, but involves very difficult techniques. Good network adaptation is effective in reducing latency while maintaining reasonable image quality. It monitors sending and receiving packet patterns and feedback to the video encoder to increase or decrease the encoding target bit rate. The most important role of this network adaptation is the detection of network congestion. If the current network is congested, we can keep the latency. We can keep the latency low by transmitting less data to the network. This, of course, leads to poor picture quality, but keeps your video calls going continuously. And let's see another factor. Loss robustness is also an important feature. Network loss also interferes with real-time communication. In fact, there are various techniques to overcome network loss. In this session, I will introduce classic two schemes, FEC and retransmission. The FEC forward error correction sends redundant packets whether the packet loss occurred or not. On the other hand, retransmission resends a packet when the packet is lost. FEC is effective when the latency requirement is strict. However, it uses more data. Therefore, retransmission seems reasonable when the data cost is high. We have organized the changes into a table in loss robustness perspective. Retransmission was used in both. As the FEC scheme, line free core is using flexible FEC technique that protects packets with two-dimensional parity FEC protection. This flexible FEC now in draft stage in IETF standardization. The new VoIP platform we implemented includes full features of the flexible FEC, which includes iterative decode scheme. The iterative scheme enhances the restore ratio, even if the lost packet count is the same. We have also changed the video streaming way to improve loss robustness. Temporal SVC stands for Temporal Scalable Video Coding. It includes non-referable frames during P frames. So, if a packet is lost, the next frame can be decoded without the I frame. Maybe you know already the network adaptation is related to loss robustness. As mentioned earlier, if it generates more FEC packets to increase loss robustness, transmission data size also increases. And the network latency would be increased if the traffic input is more than the network serving bit rate. This is called the network congestion. The network adaptation module has to detect this condition because the video call quality will be poor because of network congestion. After that, the most reasonable behavior is to decrease the loss robustness. And then, for a while, we expect resolve congestion with a lowered latency. We studied and developed our own network adaptation algorithm. We named it SysFS. SysFS represents congestion control based on forward path status. SysFS finds the available bandwidth of the forward path while maintaining low latency. And it distributes the estimated bandwidth to the H media streams: audio, FEC audio, video, FEC video. This dividing process is done during calls continuously. If SysFS detects the congestion, but the network is lossy, it will allocate some bandwidth to the video stream and some to the FEC stream. In this way, it maximizes the use of given network resources, and which is in turn contributes to the better call quality. In fact, the network adaptation was already in the old line. It used GCC for video. This is developed by Google. And it used Downy for audio. That is developed by our team. But it has been redeveloped all over. SysFS takes the role. The existing algorithms worked independently depending on the media type. So, it was impossible to estimate available bandwidth. However, the new VoIP platform is able to estimate available bandwidth with CCFS. Also, the new platform can consider FEC data usage. So, we can enhance network utilization based on those techniques. And the latest line can play Full HD video call. When these conditions are satisfied, the camera device has to support 1080 resolution. And device has to have enough processing power to handle video in real time. Finally, network condition has to be. Then Full HD video call will be enabled. In reality, we need to consider more factors, such as mobile data cost and rendering screen size. So, the Full HD video call will be enabled only on the desktop for now. Today, I share the latest update of the line-free call. To summarize, we discarded the SIP and developed the new mobile network-friendly protocols for call setup. Then, I talked to you about Full HD voice quality and the improved video call quality. As a matter of fact, all the code in the VoIP platform has changed. We have been serving the line-free call for years, but I think this is another start. And we are monitoring the reaction of users sensitively and responding with the highest priority. So far, some side effects such as noise have been reported, and most of them are already expected and will be patched. Please use more and give lots of feedback. And enjoy our new free call experience. Thank you.